Good afternoon, everyone, and welcome to the Windward Institute's afternoon webinar, Number Sense in Action, Developing Mathematical Thinkers. It is my pleasure to introduce you to your presenter this afternoon, Dr. Elizabeth Hughes. Dr. Hughes is an associate professor of special education at Penn State. Her research evaluates literacy and mathematics interventions for students with disabilities and those considered to be at risk for potential identification of a disability. Her current research explores the role of language in learning and communicating about mathematics. She has published her research in several peer-reviewed journals and has developed interventions that support language and math learning. Before her career in higher education, she was a classroom teacher in Georgia, and she is a parent of a 2E child with a reading disability and president-elect of the Council for Exceptional Children's Division for Learning Disabilities. Thank you so much, Dr. Hughes, for being here, and thank you all for joining us this afternoon.
Hi, thank you. Thank you very much for having me, and thank you for spending your next hour with me. I'm very excited to talk with you and talk about number sense and ways to build number sense at home with your children. So the way I'm going to handle questions, if you have questions, you can drop them in the Q&A, and then I'm going to pause momentarily across the presentation to answer some of those questions. I'll also have a little bit of time at the end to address any questions that you may have. Okay. And I want to open up with a little icebreaker here. So this is an activity that I call how many different ways can you say, or how many different ways can you show? So I just want you to take a look here, and we have the number 10 in the middle. And I want you to think about how many different ways can you express the number 10? And my own children gave us 2 examples there to get us started. I'll give you just a few seconds to think about this. Okay. And here on this slide, I'm sharing some of the examples that my children and I came up with. And the reason I wanted to start off with this activity, which is an activity that you can do with your kids at home with any number, is to really expand the way we're thinking about numbers. And when we talk about number sense, and we're going to be talking about flexibility of numbers, is understanding and using numbers in different ways. So here are a lot of ways that we can express 10, whether it be through 10 fingers or toes, or the word 10, or 7 plus 3, or 30 divided by 3. Okay. And I am going to come back to this idea of thinking about numbers in different ways later on in the presentation. So our agenda for tonight, first of all, we're going to say, well, what is number sense? Like, you're here to learn about number sense. What exactly is it? And then why is it important? Then I get into the really fun stuff, which is how to support it at home. And then bridging that into the classroom, evidence-based practices for school settings. Now, I have a lot of slides here, and I think they're going to, if they haven't already, drop a link to a folder in the chat. This will give you access to these slides as a handout. It'll give you access to some of the other resources that I talk about through this presentation as well. And if we don't get to all the evidence-based practices in school settings, that's fine, because you will see me again, hopefully, and we have an institute where I will be kind of breaking that down in greater detail as well. So, what is number sense? Essentially, number sense, when we talk about number sense, we're talking about the ability to manipulate numbers and to have flexibility in the way that we use numbers and number strategies. So if you think about numbers and number sense, we're talking about having an understanding of how numbers work, how numbers relate to each other, and how we can use them to solve math problems. So it's not just about knowing math facts, although that is important. It's about thinking about numbers in different ways. So this links back to that first activity that I had where we thought about the number 10 in different ways and that flexibility of ways to think about numbers. And then when we use each of those ways to solve problems. So building number sense is going to help your child be more flexible with mathematics, become a more confident problem solver. But first, before we even get into that, I want to rewind a bit. And this is going to link to one of the resources in the folder as well. So there are cute videos about each of these principles that I don't have time to go over right now, but if you're interested in watching them and learning more, it really sets the foundation for what we're doing with numbers. So those basic number principles are one-to-one correspondence, whereas each object has a number. Each flower on this slide, I could count in each one. The red is 1, orange is 2, yellow is 3. Stable order is that the numbers go in the same order. 1, 2, 3, 4, 5. Okay, and they're always going to be in that order. This connects to number lines when we talk about practices in the classroom. Cardinality is that when you're counting, the last number you say is going to be the number of objects there are. So if I'm counting red 1, orange 2, yellow 3, 4, 5, 6, 7, and I stop at 7, there are 7 flowers there. Order irrelevance means it doesn't matter in which order I count. I could start with the yellow flower or the purple flower or the green flower. And as long as I'm counting each flower once, which is my one-to-one correspondence, I'm going to come up with 7. Okay, and these are really foundations for what we're going to be doing with our number sense. And then the abstraction is that we can count a lot of different things. Any discrete items, whether they be tangible or intangible, like thoughts and ideas, we can count. So this builds that foundation. If you want to learn more, I have links to videos in the folder. But the number sense skills I'm going to be talking about today are listed here, and I'm going to define them in the next slide. So let me just quickly move to that one. The first thing we're going to be talking about is subitizing. It's a fun word to say. You can say that if you want. You can do it at home. Just be like subitizing, subitizing, subitizing. So subitizing is the ability to instantly recognize the number of objects without counting them. If you look at that third column there, you see I have green ovals, and you may look at that and be like, oh, I see 5. You didn't have to count 1, 2, 3, 4, 5 like I did with the flowers. You were able to instantly recognize that number, the quantity of objects there. So that is subitizing, and we're going to be talking about ways to build subitizing skills at home. For all these things, I'm going to give you at-home activities that you can do. The next is that 5 and 10 benchmark. And when we talk about 5 and 10 benchmark, we have a base 10 number system. So numbers that are end in 5 or 10 or multiples of 5 or 10 are going to be benchmark and really important numbers when it comes to memorizing and mental math and lots of other mathematical components. The next number sense concept is composing. And in composing, we take 2 or more smaller values or smaller numbers, and we combine them to get a larger number or a larger value. Okay. And then the opposite of that is decomposing. So that's taking that larger number and breaking it down into smaller parts. Composing and decomposing is critical. I think this is, out of all these, I would say these are being able to understand numbers when composing and decomposing is going to have the biggest impact with what I talk about today. The next number sense topic is going to be plus or minus 1 or 2. And this links back to those 5 and 10 benchmarks because Sometimes some numbers are more challenging to work with than others. But if you have a number that you can add one or two, or you could subtract one or two to get to one of those benchmark numbers or get to an easier number to work with, it helps with mental math and it helps with problem solving strategies. So plus or minus one or two is another number sense strategy. And then the last one I'm going to talk about today is doubling and the skill of doubling, which is simply multiplying a number by 2 with ease, being able to take a quantity and double it. Now, why are we spending time talking about this today? One of the things to note is that math builds in complexity. So even though some of these skills seem simple, they're really important in being able to develop that ease and flexibility, and thinking about these skills in different ways is going to have a long-term impact. It helps students to be more flexible and use more efficient strategies when problem solving. So talking about how numbers build in complexity, I have a sequence here, and this is a very simplified version of a math sequence. So this does not incorporate everything. But in that violet area, you see that I have 4 circle dots. I have 3 in one row and 1 in another row. A way that you can think about that is 3 and 1 has the same value as 4. And that's very has that visual representation. It's easy to kind of see and make sense of that. And that's one of those early skills that really young children are going to gravitate towards. Those touching and those playing of toys, moving things, moving manipulatives. And then we connect that to this abstract numbers and symbols and sequence. And we say 3 plus 1 has the same value as 4. But this time we've taken away that visual component to help students make sense of it, and it's in that abstract form. Numbers then get bigger and more complex, and when you're working with larger numbers, it can get more challenging, and students have to hold more information in their head. And then eventually move to algebra, and rather than having a number there or a value, we have a letter that represents an unknown number or value. So you can kind of see how this sequence builds. And if there's a disconnect at any one of these areas, it makes it more challenging for the students to progress to more difficult skills. So this is when we get to the good stuff. What can we do and what can you do at home? And I've broken it down into 3 things that you can do to support your child at home. Number 1 is to use math language in everyday activities. Talk about math. Explain your thoughts and reasoning. You don't have to be, and I use air quotes, math person to be able to talk about math and make observations about math at home. Another thing, although it's not directly related to this, is be a math person. And if you're not a math person, you're like, oh, I'm not a math person. What I always tell my students is fake it till you make it. When you're teaching math, math is your favorite subject, because that inquiry, that interest is really going to model to your children how to approach mathematics. So talk about math. The second strategy is going to be to build fluency and flexibility through multiple opportunities to practice. And that's really the key component here, is these multiple opportunities and varied opportunities. So you don't have to do everything all at once. But if you build in opportunities throughout the day, throughout the week, throughout the month, students or your children are going to be able to practice these skills. And one of the ways to do that is just through drawing attention to numbers, values, and variables in everyday events. Okay. I'm a mom. We're busy. Everybody is busy. After I'm done with this, I get to go home, make dinner, take my child to lacrosse, walk the dog, do all the things. I don't have time to just sit and do 30 minutes of math worksheets with my kids. So we have to build mathematics into our everyday routines. And then the third thing is to provide opportunities to see and touch mathematics. So when you think about that sequence and those abstract numbers and symbols that we're using, math makes so much more sense when we can see pictures of mathematics. And so we'll talk about ways to do that in your home as well. Okay. So without further ado, talking about math language. And this is one of the things I absolutely love. I could talk for the next 42 minutes about math language, but instead I have an article for you in the folder, in the link that really breaks down easy math language. Uh, it's I would say it's an easy digestible article, I think. It's a practitioner piece and it has my favorite parts are the tables where it says, rather than saying this, say this. So it kind of tells you what math language you can use, clear and concise math language, and then why you use that. So check that out if you want. I'm just going to highlight a few ways to talk about mathematics in the next few slides. The first, and I think this is probably kind of one of the easiest entry points when talking about mathematics, is think about relationship language. So when you're walking and you see, you can use terms like bigger, smaller, that tree is taller, that tree is shorter. I see more ducks in the pond than I see ducks in the grass. Any way that you can talk about and use that comparative language or that relationship language is talking mathematics. You don't have to use numbers every time you're talking about mathematics. Okay. So I encourage you to kind of just think about, well, where in my routines can I talk about mathematics? And it could be time. It could be how many plates are on the kitchen table. Do we have more plates or more napkins? That wasn't the best example, but you get the point. You can incorporate this into just what you're doing at the time. Okay. The next term I want to bring your, really concept I want to draw your attention to is the equal sign. So I want you to take a moment and think about, what does the equal sign mean? And when you were going through school, when you had math class, what were you taught? What was it? What did it mean? Okay. Oftentimes, we associate the equal sign with solve for. We see a number sentence like 4 plus 1 equal sign, or 3 times 2 equal sign. And so we get in this idea in our head that it means that we need to solve for whatever's missing. But in reality, the equal sign means balance. And this is a key understanding of mathematics, okay, and mathematical equations. When you see an equal sign, what it is communicating to you is balance on either side of the equal sign. Okay. So when you're thinking about balance and when you're thinking about the equal sign, what I recommend saying is has the same value as. 3 plus 1 has the same value as 4. 8 divided by 2 has the same value as 4. And if you notice, I'm using these gestures. I'm using my hands to show balance, and I have the little hands on the slide there as well. So you can use gestures when talking and when talking about mathematics to help communicate and support ideas. So when thinking about the equal sign, when thinking about numbers in different ways, going back to that 10 activity, the square root of 100 has the same value as 10. Okay. The equal sign communicates balance. Another term I want us to think about and I want to kind of clarify is fluency. Now, if you're like me, when I think of fluency, traditionally, when I think of fluency in my own education, it was those minute time test. And I'm not saying those minute time tests are bad. Okay, there is a place for them. But I always associated fluency with speed and automaticity. You need to get it, you need to be faster, you need to get it right away. Oh, I can see how that causes anxiety when you're thinking about needing that automaticity. So I want us to think about fluency in a different way. I want us to think about fluency as with ease and accuracy. Okay, take the anxiety out of fluency and math fact fluency and really think about, can you solve this problem with ease and accuracy? And ease and accuracy may mean that you can do it automatically and you have that automaticity with some things, and that's fine. But with ease and accuracy also may mean that it's not automatic, but it's not hard. What do I mean by that? Let's take the example 2 plus 1. 2 plus 1 equals, has the same value as my unknown. Now, you may have been able to get that right away. What about this one? 704 plus 108. Even if you're not able to find the solution right away, can you, with ease and accuracy, come up with a solution or a way to solve it? Can you come up with a strategy? So when we think about fluency, I want you to think about ease, accuracy, and how it relates to not only math facts and procedures, but strategies. So can I solve this with ease, with accuracy, even if I'm not automatic? How do we build fluency? Through practice, through opportunities to practice, which we'll talk about next. Now I'm going to take a quick pause to see if there were any questions, thoughts before moving on.
Dr. Hughes, we did have one.
Okay.
What are your suggestions to help an eighth grade dyslexic student who still struggles with number sense? Am I too late? Also, sending a "we are" to Dr. Hughes from a Penn State alumni.
Thank you. Oh, I love that question, and I love middle school math. And I am going to ask if I can save that until the end. I will stay on a few extra minutes to talk to you about that and about ways to build number sense. I didn't incorporate it in this, but I have some resources for algebra manipulatives, which are amazing. So stick around and I will answer that at the end. Okay? Thank you. Moving on to ways to build, opportunities to build this at home. Okay. Just a reminder, these are the skills that I am going to be talking about and breaking down for you. And I want to start with, I said it's important to touch math. What do I mean by touching math? I do not mean that you have to go to a store or shop online for expensive math manipulatives. Okay. If you want, they do have things at like the dollar store. There we go. That are math manipulatives, but anything can be a math manipulative. Okay, here are some examples. Socks, cereal, shoes, money, things that you find inside the house. When you're talking about socks and shoes, remember doubling was one of those strategies, those number sense strategies. So you can practice doubling with things like that. How many shoes? Oh my gosh, I don't even think my kids could estimate how many shoes are in our front foyer right now because there are so many. But I could be like, how many shoes? How many pairs of shoes are you putting away? If you're putting away 3 pairs of shoes, how many shoes are in that? So doubling that. It could be manipulatives. It could be things, seeing math outside. Pebbles, rocks, flowers. Spring is upon us pretty soon. Unless we get that last March snowstorm. So anything that is really around you can be a manipulative. I use all the time craft sticks and cups. Really inexpensive. Whoops. Great manipulatives. Okay. So start thinking about and expanding your idea of what math means. And here's an activity for subatizing. I call this activity, how many do you see? Because subitizing, remember, is being able to automatically or instantly recognize the number of objects. Here, how many dinosaur chicken nuggets do I have? I have 3. You probably didn't have to count 1, 2, 3 to find that. You were able to figure that out right away. Other ways that you can work on subitizing skills is vitamins in the morning. I'm pouring out vitamins in my hand. How many vitamins do I have in my hand? How many blocks do you have? How many, anything that's a small number or a small quantity that is together. Okay, how many ducks are in the pond? How many crows are in our backyard? How many bunnies do you see out there? How many dog toys are on the family room floor? Any of these things you can see with subitizing. I wouldn't have something where the objects are like really far away though, but just kind of in a close proximity, it can be subitizing. Now, you may be like, okay, well, this is great for young kids, but what about my upper elementary kids? You can still use subitizing. Subitizing, the larger the numbers, the harder it gets. So you kind of move into this, well, maybe I'm not able to instantly identify how many numbers there are, but can I, with ease and accuracy, figure out how numbers there are with strategies? Here we have 3 pictures, and in that middle picture, you see the dinosaur chicken nuggets are in an array. They're in 3 rows of 3. So I may be able to look at that and be like, oh, there are 9. But if I'm looking at the picture with the chicken nuggets in the ketchup, I'm like, I can't instantly tell you how many there are, but I might have a strategy. So as you're serving dinner tonight, how many French fries are on your plate? Or how many strawberries do you have? And then the follow-up questions would be, how did you figure that out for those big numbers? You see 2 different strategies here for figuring out how many chicken nuggets there are. Looking at these 2 strategies, you may also say, well, which one's more efficient? Counting each one by itself or grouping them in groups of 3 and recognizing that 3 groups of 3 has the same value as 9. So in kind of conclusion for subitizing, just you don't need a worksheet or things in front of you. You can do it while in the walk. You can do it while in the car. Anything around you that you can see kind of groups of, and you can automatically look at that and say that's a certain number. You can practice subitizing. When you're working with larger numbers and you're not able to instantly recognize the number, ask those questions. How did you figure that out? This is where you're starting that flexibility of manipulating numbers. Okay. The next strategy is the 5 and 10 benchmark. And this one I'm just spending a moment on because this is really going to be incorporated more into other strategies. I just want to emphasize that we have a base 10 number system. You can see the example there with place values. So each of our place values, multiples of 10, and 5s and 10s are just those easier numbers to work with. When they end in 5 or end in 0, when it's a multiple of 5 or a multiple of 10, it's an easier number to keep in our short-term memory when doing mental math. So when we think about that, think about ways to get to 5, to get to 10, so that we can work with those numbers is helpful. I told you I was only going to spend a second there. Next, we're going to talk about composing and decomposing. And if you recall at the beginning, I said this is probably one of the most important, I would say, because I do a lot with algebra work, and this lends itself so nicely to algebra. So that 8th grade, your 8th grader, this is that the composing and decomposing of numbers is going to build those algebra skills. Vitamin math. This is something that I did with my kids since preschool. We still kind of do it. My daughter's in 6th grade and my son's in 5th grade, and we still do little things like this. So one of the things you can do is subitizing. How many vitamins do I have in my hand? But then you can build from that, and you can If you have 4 vitamins in your hand, move them around in different ways. Or sometimes I shake it up. I have 4 and then I shake it up and then they're all in different places. And I say, how many now? And it's still 4. They've moved location, but the value is still the same. That's that flexibility of math. Or I may break them up in 2 parts and say how many. So here you see different examples of ways that I can talk about math with just 4 vitamin gummy bears. Okay. Other ways that I do this, sometimes I may pour out and have like 7 in my hand. And I'll make my kids make number sentences. How do you know that your mom is a professor that focuses on math education? She's making you do number sentences with your morning vitamins. But they may say 7 minus 2 equals 5. Or then I have 5 and I go to my next kid and I say, okay, if you take 2, how many am I going to have left? 5 minus 2 equals 3. And so we talk about math in that way. And then connecting to schools, I mean, again, vitamin math seems very simple, but it's going to build in complexity. So you see examples here of ways that number sense, or I'm sorry, composing and decomposing numbers builds. Okay. And depending on whether you're going to the number with a greater value, you're breaking it down to smaller parts. You see different examples here and different ways to show it. In the one in green, it is by place value. Although when it came up on the screen, I can see it looks a little weird. It looks like a 24 and 6, but that's supposed to be 246. And then that circle is supposed to be 200. Okay. And again, that's going to lend itself to algebra. So here's an example of something that I do with my kids at home sometimes, or I did, especially when they were little. Those are my daughter's hands when she was in kindergarten. So this was definitely a few years ago. But this is a simple activity. If you don't have little cubes like that, you can use Legos, you can use blocks, you can use pennies, you can use whatever. If you notice my plus sign and my minus or my equal sign are just pieces of torn paper. I did that purposefully to show that it's easy to do at home. So in this activity, we build and I say 3 plus an unknown number hidden under this Tupperware has the same value as 5. And I asked my kiddo, how many blocks do you think are under this Tupperware? And she would guess and she would predict, oh, how many blocks do you think are under there? And then say, okay, let's find out. And so you can kind of see her pulling up the Tupperware to see that there are 2 there. And we put them together, we build that, and we check our answer. So this is something that you can do where you have a number of objects and you hide a certain number under a Tupperware, under your hand, take them away, whatever, and you're having students or your children try to figure out how many you have, how many are missing. Okay. What's nice about this activity too is if you notice my missing number is not on the other side of that equal sign, but it's part of that first equation, that first half of the equation. So the missing value can be anywhere. How does this build into algebra? This is what you could do with your kind of older students, your upper elementary students. So here is that same concept, the same idea, only I have my Tupperwares. I have 2 Tupperwares this time, and I tell my child, I have the same number of blocks under each Tupperware. Okay, so I have 5 plus 2 groups of something has the same value as 11. How many blocks are under each Tupperware? And then in that second picture in the middle, you can see that I actually just used a Sharpie and drew an X on that. That was more for kind of sharing how this relates to algebra than working with my kindergartner at the time. But I'm showing here that that's 2X. So we're building those algebra skills. And then again, we're practicing and we're checking. And through all this time, I'm talking about mathematics and I'm modeling my thinking. Okay, I'm going to take a pause right here to see if there are any other questions about subitizing, about composing and decomposing numbers before we move on.
I currently don't have any new questions.
Okay, sounds good. We'll move on then. My next example is for plus or minus 1 or 2. And the plus or minus 1 or 2 strategy really connects back to that 5 and 10 part of number sense, because plus or minus 1 or 2 is helping your child get to easier numbers to work with. You want to be able to, you're holding all of that information in your working memory. And so being able to work with an easier number is, well, I mean, simply put, easier. So practicing plus or minus 1 or 2 gets us to working with easier numbers. I love using sports in mathematics. Sports lends itself so beautifully to mathematics in so many ways. I'm going to be talking about the score here, but you can also look at and talk about how they did over the year. Eagles were 18 and 3. What does that mean? Which is a greater value, their wins or their losses? There's so many ways to talk about math in sports. And hopefully there aren't any Chiefs fans in here that I'm upsetting with this score. Being in Pennsylvania, I was go Phillies. But back to math and plus or minus 1 or 2. My question here is, and it's a question you can ask your child, what's the difference between the two scores? And difference is a great math term. Okay. And then that follow-up question of, well, how did you figure this out? How did you solve that? And this is where that plus or minus 2 comes in. And I'll show you on the next slide. So one way to solve this problem, to find out the difference, is to say 40 minus 22 has the same value as something, and use that traditional way of solving math. For me growing up, it was that 40 on top minus 22, start with the ones place values, then borrow from the tens. Very traditional algorithm. It's a fine way to do it. But there are other strategies and different other flexible strategies that can help with mental math as well. And so I have here some of the dialogue for that. You could recognize that 22 is 2 more than 20. And I know 20 is one of those 10 benchmarks. I can mentally subtract 40 minus 20 equals 20. So if I can hold in my memory that, well, I had 22, so I took 2 away from that to get to 20, I'm going to put those 2 back in at the end. I have 20, or I'm sorry, I have 18. I totally messed that up on that slide there. And then I add back the 2, I get that 18. Ignore that 22 there. I will change that and fix that. One of the things I love to do, even when I was a teacher and I taught 4th grade, if I ever made a mistake and my students pointed this out, or in this case, if your children pointed out, I'd always be like, you know what? I put that there to see if you would see that. And you did. You are so smart. So I can just say that I'm like, I just put that error in that bubble to see if you would find it. But that was actually an error. So that plus or minus 2 is going to find numbers that are easier to work with. You could say, what's 18 plus 2? What is 19? How would you get from 19 to 20? There's different ways you can talk about and have your students just practice adding and subtracting 1 or 2 to numbers to get to those benchmark numbers. Okay. Moving along to doubling. So doubling, I said sports is a great way to practice mathematics and just talk mathematics. Cooking and baking is another great way to talk about mathematics. And what I love about cooking and baking is it naturally lends itself to fractions as well. So you could talk about, you can use all that math language, greater than, less than. You can talk about adding and subtracting. How much dry ingredients do we have? If we have 2 cups of this and 2 cups of this, you're composing and decomposing, but it also lends itself to doubling. So you might have this recipe, and you can, as you're cooking and working and following a recipe, just say, how many cups of flour do we need if we're going to double the recipe? You don't actually need to double the recipe, but you can just kind of have these math conversations. Or how many cookies will we have if we double the recipe? Going in that direction, you can also kind of think about doubling going down. Well, what if we half the recipe? What if we only want to make half of the cookies? How many cups of flours will we need in that case? And so you're talking about mathematics and starting to think about those doubling to make it doubling or halving different things. Okay. This also lends itself to then thinking about mathematics in different ways, such as dividing fractions, which is a really difficult concept to kind of wrap your head around sometimes. Even me, when I'm teaching dividing with fractions, I'm like, okay, wait a second, make sure I get this before I say anything. Here is a word problem, or just a kind of a problem that you can problem solve, that is division with fractions. I need to add 2 cups of chocolate chips, but I only have a 1/2 cup measuring cup. How many 1/2 cups do I need to add to get 2 cups of chocolate chips? And so essentially what we're saying is what is 2 cups divided into 1/2, or how many 1/2s are in 2 cups? And you find out that it's 4. 4 1/2 cups are needed to make 2 cups. Okay. Your child doesn't need to know that they're doing division of fractions to kind of start making sense of these word problems and how to manipulate numbers and be flexible with numbers to solve problems. Along with the cooking, other things that you can do are kind of those strategies again, that subitizing, how many do you see, composing or decomposing, how many different ways can you group these cookies? We have 12 cookies. How many different ways can we group them? We can group them in 2 groups of 6, 6 groups of 2. We can group them in 3 groups of 4, 4 groups of 3. So you're talking about multiplication if you have equal groups, or you don't have to have equal groups. You can talk about addition and subtraction if you're doing them as 1 plus 3 plus 5 and so forth. Okay. Any way that you can increase just talking about math. And then the last kind of at-home example I'm going to share is that estimation. Estimation can be a really challenging one because it's really abstract. So I don't want you to kind of overthink the complexity of this. We just want to start talking about and thinking about mathematics. When thinking about big numbers, you can be able to, how many tulips do you think are in that field? And why do you think that? Other ways to incorporate estimation discussion is, how many steps do you think it'll take for me to walk from the front door to the car? How many steps would it take you? What if I take giant steps? What if I take baby steps? What if I hop? What if I skip? You can talk about who has bigger steps. I have bigger steps than my son, so it's going to take me fewer steps to go the same distance than it would take him. Again, fewer, greater than, just using that comparative math language. So I shared different ways to incorporate number sense in things that you're already doing at home. What I kind of want to say in conclusion and kind of wrapping it up is, do what you can to just start making it a habit to talk about math. And you don't have to be perfect at it. No, you can make mistakes. I modeled that myself here. But just talking about it and become more comfortable discussing it and incorporating it into your day-to-day life, because math is all around us and it is really a part of everything. So any observation and connection you can make can have impact on your child. Here I have just different ways to think about mathematics and ways to, or think about how you're going to incorporate that and remind yourself to incorporate it. When making habits, we need to like remind ourselves to do that. Other things you can do is just practice math mindfulness and read a book, or while you're reading a book, talk about how math is a part of the book. There are books about math. Some are better than others. I can provide a list of that if you are interested. But there's lots of ways to kind of make it work with what you're doing. I'm going to take a pause again now to see if there's any questions in the chat. And I know we're pretty close on time as well, and I will leave questions or time for questions at the end.
Currently, no additional questions.
Sounds good. Okay, so connecting this to the school setting. Oops, my computer is, there we go. Okay. There was just a few years ago, the What Work Clearinghouse through the Institute of Educational Sciences published a manual on evidence-based practices for elementary grades. And in it, they had 6 evidence-based strategies. This is available on the IES website, and it is, what I love about it is it really breaks it down into tangible ways of thinking about these things. But they had 6 recommendations. The first is systematic instruction, which I know they incorporate a lot at the Windward Institute. The second is using clear and concise mathematical language. The third is using representations, whether it be tangible representations, like things you can touch, visual representations of mathematics that you can see, or virtual manipulatives that you can use online. The fourth recommendation is to make connections to the number line. Now, I will say from experience, some children gravitate to the number line more than others. And for some kids, the number line makes sense more than others. So there's a lot of good ways that we can connect things to the number line and incorporate representations in clear and concise language. The fifth one is looking at how we talk about word problems. Word problems can be really challenging, especially for students who have reading disabilities. And so thinking about the underlying structure of the problem as opposed to finding keywords within the problem is really beneficial. And then the last one is that timed activities. And I know we think about like that mad minute of math facts and like math anxiety, but spending a little bit of time each day over a long period builds that math fluency. So it's not a bad thing, but a lot of it could be how we approach things. I'm going to fly through these slides. I'm going to share things. I'm not going to go through each of these components because there is a institute that I will be doing that will do a deep dive into this. But I just want to kind of put this out there. So in case this inspires any questions or any thoughts, you will have it, and you will have access to this in the folder as well. So using clear and concise math language when talking about mathematics, giving your child opportunities to talk about mathematics, and it doesn't have to be formal. Using representations, and this is a slide I'm really going to go to. When we think about representations, think about it fluidly moving from the concrete to semi-concrete to abstract, and there's lots of different ways that we can interact with mathematics. Okay. Thinking about the language of mathematics with, it's not just listening, but it's also reading and writing and speaking. So as we're thinking about all these different things, I mentioned an article that supporting clear and concise math language. That article should be in the folder that you have access to. Take a look, even if you don't want to read the article. I like the visuals. That's one of my favorite parts of the article, are the tables, because they're just easily digestible. Okay. Number lines. I have a few visual examples of the number lines here and ways to use the number lines. These examples came directly from the IES book. So download that for free. The examples are great. And then word problems, tossing this out here. This is a big thing I want to kind of share. Keywords are not effective. So when you're working with your child at home, when you're working on word problems, I know I was taught keywords growing up. I actually know that I was taught to teach keywords as a teacher. Now I know better, so I do better. And I want to share an example so that you understand why keywords are ineffective. If you take a look at the word fewer, I have two word problems here. And the green word problem, fewer works. I could use the keyword and I could come up with the correct solution. However, in the red problem, I'm also seeing the word fewer, and it doesn't get me to the right solution if I say, oh, fewer means subtract. So the word fewer is really important in this problem, but we don't want to associate if you see this word, then you do this action. The way to solve that is to teach underlying schemas, which we'll talk about at the Institute. Okay. Timed activities. What I want to point out here is there are different types of timed activities, and there are timed activities that build connections and understanding of mathematics that don't have to cause stress and anxiety. And that's where I'm going to pause for questions and discussion. I know I flew through those past few slides, but that is fine because there will be another opportunity to really do a deep dive into those as you see it here with that all hands on deck. So we have about 5 minutes left in this time, and I can stick around too to talk if you want, but I want to make sure I answer any questions that you have. Okay, so if people are thinking about questions, or typing them, drop them in there. If not, I have a question for everyone out there, and I want you to think about 3 ways that you will talk with your child about math this week or next week. So think about 3 different opportunities that fit into your everyday routine where you can talk about mathematics or make observations about mathematics and number sense.
We did get a question that just came in. Can you teach keywords in conjunction with schema?
Good question. So keywords are important. I mean, they're key for a reason. They communicate something in the word problem. Where they become, let me scroll back. Where it becomes negative is when you're saying, let me scroll back 2 more. If you see this word, then you do this operation. That if then relationship is where it becomes problematic, especially for our students for whom reading is challenging. It's much easier to find a single word in there and decide what to do than read the whole thing or listen to the whole word problem and make sense of it. Sarah Powell did work, and she found that in single-step problems, keyword solutions got you to the correct answer about 26 to 81% of the time. Okay? But once you're working on multi-step problems, it was 0 to 29% of the times. And the study she looked at, the median was 5%. So if that's the only strategy we're teaching, that if you see the word altogether, you add, if you see the word fewer, you subtract, we're setting kids up for failure. What we can do instead is teach the underlying reasons why we add or subtract. So for example, for addition and subtraction, which we teach together because they're reciprocal, there are 3 reasons why we add or subtract. Either you're combining things, apples and oranges come together for a fruit basket. You're changing something because there's an increase or a decrease. I had $10, I earned $5, I spent $7, or you're comparing things. So that 22 to 40 score. You're comparing the score from two different teams. So those are the reasons why we add or subtract. And teaching students to recognize what's happening in the story will then help them set up the problem better and solve the problem more accurately. Does that answer? I know that's a long answer to your question. So yes, like teaching students to focus on those words is important, but it shouldn't be a, if you do this, then you do this.
Is there normed assessments that you would recommend to measure students' number sense to inform instruction, etc.?
Ooh, that's a really good question. So I will say our math assessments are a few decades behind reading assessments. I would have to think about that and share, because there's different, there's not one that I would consider that comprehensive, especially because you want to connect it to instruction and informing instruction. So for example, I don't think there's like a subitizing assessment that will inform instruction. That's just a kind of something to build through practice and over time. When looking at, I think something to inform instruction is error analysis. So looking at what errors the students are making, and if they're making these conceptual errors, especially when you're talking about composing and decomposing numbers, that might inform instruction. So I think error analysis is a good way, especially with mathematics and word problems. But I will have to think about that one as well.
Thank you for joining Dr. Elizabeth Hughes and the Windward Institute for today's webinar. For more learning with Dr. Hughes, join our virtual workshop on Thursday, April 3rd. To register, visit our website, www.thewindwardschool.org/WI.